All right, so we've gone over how to find areas. Now let's figure out volumes next. Now volumes depend on areas. So the volume is equal to the area times the depth. So for example, and I'm on page 615, okay? If I want to find this volume, what I'm going to do is I'm going to find the area right here. It's 2 feet by 6 by 3 feet, otherwise known as 6 square feet. Right? The depth is 9 feet, so I'm going to take that 6 square feet times the 9 feet, and I'm going to come up with 54 cubic feet. Okay. Now, when we're moving dirt around or cutting or filling, we call out cubic yards. And when you go to buy bark dust at the garden shop, they call them yards, but they're actually cubic yards is what they are. They're a yard by a yard by a yard. 1 yard is 3 feet. So a cubic yard is 3 by 3 by 3 feet. It's 27 cubic feet. So we got 54 cubic yards, and we know, cubic feet. And we know that 1 cubic yard is 27 cubic feet. So what that gets us is 2 cubic yards. So that's how many cubic yards you got there. And like I say, people often call them yards, but they're actually cubic yards. It's 3 feet by 3 feet by 3 feet. So if you take your cubic feet, which is what we measure things in the field with our instruments, you got to take cubic feet divided by 27. That'll get you cubic yards. Okay. So the general formula there is to take the area, the cross-sectional area, and multiply it by the depth. Now, so we good with that? Okay. So there we go. All right, now, as you see on page 615, we don't always have the same area on both sides of the depth, okay? So if the area changes, like you see there, you're going to have to find that first area and the area in the back. Okay? And they're not the same anymore. See, they're different. So what you want to do then, your best cut we can take at this is to find the average area. Now when you start getting into irregular shapes, like what we have in surveying, this doesn't do a perfect job. It tends to overestimate a little bit, but that's okay because contractors like it when we overestimate how much fill they're putting down. They get paid more, and that's good. They like that, okay? So even though this overestimates, it's used a lot for fill, for cut and fill. Now, if you're doing something expensive like blasting rock, doing something like that, they often don't use this formula because it's overestimates, and rock is expensive to blast. Sometimes you actually have to drill rock when you're in bedrock and put dynamite in there and blow it up. And that costs a lot of money. So if you're doing that, you use more exact formulas. And if you've ever used a program called Civil 3D, it'll do things a little differently. It'll find the volumes between surfaces is what it'll do. So when you write up these contracts, which are always done before you do construction, you have to specify what method you're going to use to calculate the volume. There's different ways to do it. Okay, this depth is 9 feet. So I would assume that volume in cubic feet then is what? 12 square feet times 9 feet, which ought to be about 108 cubic feet. But of course, we talk about cubic yards. What does a dump truck typically hold, a big dump truck? What's that? 5, okay, yeah, they come in different sizes. They have sideboards on them they can put up to. They go 5. I've seen them as big as 9. Okay, so, okay, but those are numbers that people know. Okay, so what we're going to do here is we're going to take 108 cubic feet 1 cubic yard divided by 27 cubic feet. And we're going to get 4 yards cubed. Okay. You doing all right with that? What's that now? Yeah, about 27? Yeah, 27 cubic feet in the yard. Okay. All right. Now let's apply that to what we've been doing. Here's the formula. It's called the average end area formula. This is on your formula sheet too. It's over there on the left. And this incorporates everything we just did. You take the first area plus the second. You divide by 2. That gets you the average end area. You multiply that by the distance between the sections, and you divide by 27. That's how you calculate volumes with the average end area. And that's on your formula sheet on the left. Okay. All right. So if we use those examples that we were just using, here are the 2 sections that we calculated the areas of, if you remember that. I'm on page 616. Okay. And if this is, so what I have a 3D sketch, an oblique sketch. Here's station 0 plus 50. Here's station 0 plus 90. So what? Those are 40 feet apart, right? You all good with that? 40 feet? 90 minus 50 is 40 feet. Good. Okay. Now we got the area in the front, the area in the back. We add them together, divide by 2, multiply by the 40-foot distance, and divide by 27. So if that's what your fill looks like, your berm, that's going to be 291 yards. Now, generally speaking, we round to the nearest yard, okay? That's just a convention that everybody follows. I remember when I started working, they told me if a dump truck goes around a corner too fast, they're going to spill half a yard anyway, so who cares, okay? Nearest yard, plenty good. All right. Okay? So that's how you do that, okay? And it's right on page 616. I did it all for you. You know, that might be worth marking out, I don't know, but I've got a different example on page 617, okay? That'll run through this. We got time for this. Okay, we good? So there's a berm, a long, thin pile of dirt. Let's find the volume between 140 and 297. And people don't like calling it dirt. They call it material. It sounds better, I think. And actually, it's not always dirt. It's more like fill. You know, it's not topsoil. That's what I call dirt. This isn't topsoil. You know, well, that is, but engineering stuff isn't topsoil. It's the stuff underneath. It's the grainy stuff with sand and silt and things like that in it that you can make good fill out of, okay? So let's find the volume. These are the sections down here. This is where we took the cross sections. Okay. So I've got them arranged, stacked, one after the other. So we got a section at 1 plus 40, 182, 240, and 297. I'm on page 617. Okay. So what I got to do is I got to find the area of each section. So those ones on the top are trapezoidal areas. The one on the bottom is a 3-level section. So I go through and run the numbers on that. This is on page 617. Okay. Then what I do is I do the average end area formula. A1 plus A2 over 2 times the distance over 27. Okay. So I'm going to take the area of the first, 184, plus the area of the second section, which is at 182, so that's 416. So 184 plus 416 over 2, that's the average area between them. The distance will be 42 feet from there to there. It's 42 feet. That's the difference in the stations. And then I multiply those together and divide by 27. I get 467 cubic yards. And I repeat that process. Every time I've got a new section, I do that again. So this area here is 265, so that's 416 plus 265 over 2 times the distance, which is 240 minus 182, that's 58 feet. Over 27, 731. Okay. Now the last section is the end of the berm. It's where the berm ends. It's where it comes back down to what we call the original ground. We got to call out that point. The party chief has to make a call and say, this is it. This is where it came back to ground. That's a zero section. There's no fill there. Before that, there's a little bit of fill. After it, there's none. So they call that area out as zero. Okay, that's called a zero section. So that has to go into that last calculation because the berm doesn't end at 240. It goes to 297, and then it stops at 297. So 265 plus 0 over 2 times the difference, which is 57 over 27, 280. Okay. So we go in we do jumps. Two sections, next section up, next section up. You just keep walking through the project, and you get to the end, 1478. Okay. So that's how many cubic yards. Yeah, question?
So, practically speaking, if you're building a berm, how do you determine what it is at the top?
You do a cross section, just like what we did. And I'm simplifying this a little bit because I don't want us calculating areas, forever. But what you would do, I actually used to do a lab out on the berms out there. I changed it for the drainage study, but you just run cross sections, and you'd put together a more complex figure than this. But just for the class, I kind of cut it back a little bit. But yeah, you just run cross sections. You run them before you put the berm in, so you got original ground, and then you run them after you put the berm in. You put the two together, you get the area in between. Okay. All right. Now I did this for a living once one summer. Contractor checked everything I did because, if I made a mistake, we were going to be hearing about it. And now I bet if I overdid it, I don't think we'd hear about it. But if I underdid it, I'm sure we would have. Okay. Because this is their paychecks, and they cared about this. All right. Okay, let's just do one. Do you have this page? 619? Let's just knock this out real quick now. 620. 620? Here we go. Do the one on the bottom. We got a zero area. Just real quick, let's knock this one out. Okay. So this is 620. I've changed it. It used to be 619, I think, but now it's 620. Is on the older books, is it 620? So find those areas and then do the deal. We'll do the one on the bottom and the zero area out the bottom. Yeah, so you got to do this in two jumps. You can't do it in one jump. You got to do two jumps here. So 620. We got just a couple minutes. You got questions? 124 is the station. It's not what I have to do. So that's exactly what the difference between 10 off your elevation. But then now, so this is the page to mark for the homework. The homework looks a lot like the bottom of this, or that one we went through before. That's what the homework's based on, okay? And we're doing the one on the bottom too, because we're doing it at home. Yeah, okay. So that don't look right. You got the older book. Yeah, that older book, you want a zero down there. Yeah. I changed it just a little bit. You got that little book. You want to put that 0 down there. So if this doesn't say 0, put 1 down. You should say 0. Yeah, that's it. That 0 is at 1 plus 94. Okay, so get the areas first. Okay, so these are just trapezoids, real easy on the areas. Average width times the height. I think that one's 160. The other one's, is it 300 for the other? Something like that. Okay, then you do the volumes in 2 jumps from 1 plus 0, 0 to 44 feet, right? And you got to do another jump to 194. Then you add your results together and get the total. And I don't know what the answer is, but I'm sure it's something pretty good. All right. And you got that little book, and I have to put that 0 section in there. I've changed it just a little bit. So we got 160 and 300. There's yards. You don't generally do fractions of yards, it's just convention. Now I'll keep the fractions when I add them up, but when I'm done, I'll round it. And if I'm on a job for real, I'll round them up always, just keep the contractor happy. This is 505.2 for the first one. Oh yeah, I think I screwed something up. 374? Yeah, you're probably right. Thanks. So 480 over 2 is 240 times 44. Divide by 27. I'm getting all sorts of crazy numbers here. Okay. I think I rounded them up, so I don't know. Let's see. Oh, that's 460. Okay, so 374.8, and then we got what? We got 300 plus 0 over 2, and this will be what? 50 feet? And we divide that by 27. 277.8. You okay with that? And just add them up. Okay. So you got the homework written down? I'll put that in Moodle too. Okay. I think we're running over, so sorry about that.
I'm not sure. It's like I said, it's back here.
Let me save this first thing in a second.